Hi guys, today I'm going to show you something that has been driving a lot of us crazy, and that is the red prop on the Inspire 1. This red prop, we've got two mounts that are out now. We've got a T mount, we've got an LS mount. They're both very similar, but they still have the same problem, whereas this red prop is annoyingly loose. And before I flew, I wanted to find out what was going on with this thing. So I did a lot of measurements. I measured all of the pieces because I've seen all of the fixes that are online, and you know, everybody has an idea for a fix, and I wasn't really comfortable with those ideas because a lot of those ideas were separating this propeller from its center mount, and that center mount is what keeps this propeller centered. I didn't like that at all. Putting the foam in there, I didn't like that. I wanted to find out, I wanted to get right down to what is going on with this thing. So what I did was I measured every single part, and I came up with what was going on, and I found a dimensional gap for some reason in the red mounts versus the white mounts. So what I did was I came up with a shim system underneath of the mount that goes in the piece here. It shims it up, and what it does is it puts more pressure on this propeller, which is what you want to keep everything centered. I'll show you that. I'm going to show you a diagram. I just drew a diagram. I'll explain what is going on here, but the main purpose was to find out what is truly wrong with this mount and how can we as hobbyists best fix it so that we're not causing problems down the road, or that we're not just putting a band-aid on that might fly off. So I've come up with what I feel like is the true solution for this problem. So here we go. I'm going to go to the diagram and try to explain this, and then I'll show you a quick way to install this shim that I made, and you guys be the judge. Let me know what you think. So here we have the mounting plate and the lock system for the props, and this little bump here is what engages into the center of the prop, obviously. And the biggest thing that you want to focus on is getting this fully engaged into this area. So when I measured quite a few of these, I have a lot of these, and here's one. Let's see if we can get this in the shot there. That little part that sticks up right there is actually slightly tapered. It is just slightly tapered, so that when the prop comes down onto it, it really needs to go all the way into the propeller, absolutely all the way. It needs to be a snug fit. I've got this upside down because it might fall out, but there you go. It needs to be a snug fit all the way into the propeller. You do not want that to be a partial fit. And right there, just barely wants to hang on, but that's because it's tapered. If you can see that little gap, it's actually tapered. So you want that to be snug. So you want this and the prop to be snug. So, you know, some people are putting, gosh, even DJI gives you these little pads of foam to put either inside the prop, or you can put foam on top of this piece. You can even double it. You can put a piece here, you can put a piece inside the prop, and all that's doing is it's eliminating a little bit of vibration, and it's putting pressure on these areas here. So what it's doing is it's keeping the propeller from fully seating on this central area. And this is what centers your prop. These don't center your prop. This centers your prop. This piece is bolted down to your motor. depending on what mount system you have. The new mount has an aluminum plate right here, but it's still bolted down to the center point. This is the center of your motor. You want the prop to be centered, right? If you don't have that down all the way onto this piece of plastic right here, that's the center of your motor, then your prop could be off center and it could cause a wobble. That's not good. That's really terribly bad. I mean, that could do a lot of things. That could wipe out your electronics if the vibration is too bad. So putting shims on this, even though that's a quick fix and it seems like it's doing okay, that's not really good, because you're not seating this area. This is the central area of the prop all the way down onto this central area, which is the center. They need to be tight together. It's a have to. So and if you dry fit these together, you'll see what I mean. There's absolutely no wobble whatsoever when you dry fit them together all the way. There is no wobble. So what's going on? Well, what I discovered in the red props, the red mark props, was tolerance differences. And it's kind of surprising that this hasn't been fixed yet, but obviously a lot of people have come up with some ideas on how to do this, and I've been experimenting with this with different shim materials now for over a week in different thicknesses. And finally, what I've come up with is a shim that fits between this plastic and this plastic, and what I've come up with is what we call a 7/1000 shim. So that's in English, that's 0.007 inches. That's pretty thin, but in the tooling world, that's a lot. Molding and tooling, that's actually a lot of material. So what I've discovered is that if I put a shim in between this piece, this red piece that I've got drawn in red, and the outer lock, then you get a good press between this surface and the lock. So this surface and the lock. So what's happening is this red piece is going up 7/1000 of an inch. So that's pushing it up into the prop to lock tighter. And that's exactly what the white props have. The white props have a less distance between here and here. And so they fit tight, or they fit snug. So what I've discovered is 7/1000 gives you a nice fit that feels almost exactly like the white props. Now I've gone more than this. I've gone up to 0.100 of an inch, which is just a tiny, tiny, tiny bit more than this. But it's hard to unlock your propellers. The fit is really snug when you turn these top locks to lock the prop. It feels super snug, but it's really, really hard to unlock. So again, I've tried a lot of different materials, and I've come up with this 7/1000, which makes it feel exactly like the white propellers. Now, there may be some differences because there could be, who knows if they're modifying the mold or have modified the mold already. There could be differences in the material shrink, but 7/1000 seems to be a good number for the shim that goes in between here. And we're going to go take a look at that right now to show you how that works. All right, here we have all of the parts that we need. And this is the shim that I made out of, this is actually a 7/1000 thick type of Teflon sheet. And it has a double sticky side to it, so you can peel. This is paper. You peel the paper off, and it's sticky, but the reason that I wanted to choose a Teflon type of material is because it acts like a slide or a bearing. I did try other materials. I've tried a lot of different materials, from paper to ABS plastic, nylon plastic, Delrin plastic, which is very, very good. But some of these materials are not available in this thickness, or at least not easily available. I'm in the plastics business, so I can find plastics that are pretty tough to find. But as far as saving money, this was available out of a catalog, which made it very nice and convenient. Plus, I like the fact that it's Teflon, and it seems to be the right thickness. So again, this is the shim that I designed, and it fits onto this mounting plate, but it goes on the back side because, again, what we're trying to do is we're trying to push this plate all the way in to the propeller. You don't want there to be a gap at all. And the idea that people have been putting shims on here to try to get that to fit better. Well, they're getting to fit better, but this is exaggerated. But it leaves a gap, and you don't want that. You do not want a gap, because again, this piece is what centers and holds your propeller solid. You want this piece all the way in, as far as it'll go, snug. And the only way to do that is to jack this piece up. So what we do with the shim is the shim goes on the back side. So it goes on the back side like that. And then when you put it in the locking mechanism, so it goes between the two pieces, which is then making that gap, as I showed you in my drawing, makes this gap 7/1000ths of an inch smaller. So now you're putting pressure on this center piece all the way down to the bottom with the propeller, which is the way it should be, the way it's intended to be. Obviously, this is not the same as everyone's mount. This is the new LS mount, but it's still, this principle still it does apply to the previous mount, the T mount. I used to have those. I'm just replacing with this new LS mount. It just has a little bit different locking system, but it's the same thing. So anyway, you can see how that fits on the bottom. And again, it just pushes this piece up 7/1000ths of an inch. And it's still centered because, again, your bolts are still going through, into the motor, and it's still, the motor shaft is still centering on this piece. So essentially, you're getting a good, true fit into your propeller. And again, you want this piece all the way in there snug. Just pretend like I'm squeezing on this. That's what happens when you put that shim in there. It squeezes this. You do not want to have this propeller separated from that piece by putting shims. You do not want to put shims on this. It'll fit correctly if it's pushed all the way into the propeller. And what I've done is I've got, as I just mentioned, I've got this material is it's a self-adhesive material. You just have to separate the paper, peel the paper off. Just like that. And then this piece, fits on precisely over this plate. It's a little bit tricky, but it does fit correctly. and it's made of Teflon, so it will act as a good bearing surface. Whereas if you had paper or a different type of plastic, you might create too much friction. So there you can see, and it won't come off. You know, it fits on there precisely. The double stick adhesive that's on it is an acrylic, so it's weather resistant. You know, so now you've got a nice bearing surface, plus you've just moved up that plate 7/1000ths of an inch, and it turns wonderfully. You know, it's not sticky. It almost feels exactly like it did before, except the plate is up 7/1000ths of an inch. So you're pushing this piece up 7/1000ths of an inch into the propeller, and you don't need those silly foam pads in there anymore. You can still put them in if you want to. That's not a big deal. The main thing is that you're getting a better lock, a much better lock in this dimensional area, as I showed on my drawing before, and you're engaging this centerpiece all the way into the center of the propeller, which is what you want to do. These big machines, you do not want vibration, and if you separate that prop from that centerpiece, there's the chance that you're going to get a tiny amount of vibration, and those tiny vibrations are what can really mess with your electronics and your navigation system. So you're trying to do everything to eliminate that, and this seems to be the actual correct fix for the red propeller locking system. Here we have the red prop set up with the 7/1000ths spacer, and a lot of people do like this wiggle test, and what I've noticed that in doing that, there's absolutely no play whatsoever. There's no gap anymore. There used to be in this area of the mount. The only thing that's moving now, if you feel it very gently, is actually the motor on its shaft. The motor shaft is the only thing that you feel any kind of slight movement. There's none whatsoever. Now, other people are doing this rotation like this, and that's fine. You can see it moves a tiny, tiny, tiny amount, but that's exactly the same as the white prop. So here you can see that, you know, it actually has a nice click and a very nice tension feel to it. So let me slide over the white prop, and here we go again. If you do this wiggle back and forth, it's moving. If you look at the two arrows, it's moving almost exactly the same as the red prop now, and you can do this wiggle waggle up and down. You get the same feel as you get now in the red prop, and obviously it has the same. It actually has a little bit more tension, downward tension on these locks, holding the propeller down onto that plastic centering piece, which is this piece, which is exactly what you want. So the red now has a little bit more tension than the whites. And anyone with a keen eye will see that this is not exactly the Inspire series machine. This is actually the M100, but it does use the exact same motor and propeller mount. Let me get a better view of this. This machine is known as the stripped down Inspire. This has almost everything the same as the Inspire. It even uses the same camera system as the Inspire. Same flight control. Everything's the same, except this is a stripped down version made for development purposes or made for just experimental purposes. And we use it for different things. We can put an additional camera on the bottom. It has a mounting system on the bottom we made a custom mount for a project, but this is the same thing as the Inspire. It has the same same dimensional layout. Everything is the same. So that's why I'm showing this. I just don't happen to have my Inspire here with me today. So that's what we have going on with the correct fix for the Inspire red prop problem. Again, leave a comment if anyone's interested in this piece, and I'll see what we can do. I did cut these on the laser. I have a program to cut them. It's just a matter of getting some time to do that. So hopefully I can arrange some time to get some of these made up, and we'll see how that goes. But there you have it, guys. That should be the cure-all, at least for now, until DJI gets a dimensional situation fixed with their mold. So let me know what you think, and please subscribe. I'll try to get more technical information out when I get some time on this and other projects. And happy flying.